Hello students. So today we'll be moving on with the next part of the chapter, that is analysis of a simple truss. So what is a truss, guys? I hope all of you are familiar with this kind of roof trusses where we normally see in godowns, and we see railway stations, theaters, etc. Normally these type of trusses are used just to cover the larger area. If we normally, this type of structure is made up of steel, and for a larger area to cover, if we go for the RCC structure, then it is difficult for us to provide the columns, so it becomes the hindrance. The working area or the usable area get hindered, so that time we'll be going for the roof truss here. So we need to know that is the parts of the trusses, that is, it is called as the bottom chord. This is the top inclined part, that is, we call it as the top chord. This vertical is nothing but the central post, we can say. So here this is the inclined part, and the vertical part inside what we are having, that is, one it is called as a strut, and one more it is called as a sling. So one of the basic important that we need to know in the truss is first thing is not all the members in the trusses are subjected to a tension and a compression. Normally tension as well as compression. If I consider the free body member of any truss, always it is axially loaded. That means axially loaded means I can pull this or I can push this inside. So that means either it will be under the compression or it will be under the tension forces. So no moments will be developed here. So when I say you this is a truss, at the joint I can only apply the vertical force as well as the horizontal force, but I cannot develop or I cannot resist the moment. So always remember one thing, that the truss members is always subjected to tension and the compression forces. And second thing, we need to know always the summation of fx, summation of fy, and summation of m. So all these are nothing but it should be zero, the static equilibrium condition, what we say. So these two main basic reason we need to know. So here while we are studying the truss, we need to know that is there are two types, that is, one is determinate structure, and one more is indeterminate structure. So I shall tell you only the basic thing. So the remaining part you will be studying when you go for the higher semesters. So determinate structures and indeterminate structures, what are the difference? So first and foremost, when we say, so here you can see here, guys, there is a one beam which I have shown here with some point load and a UDL with some reactions developed here I have shown. So these reactions will be developed based upon the end condition. So end conditions are nothing but the supports. So in my previous class you might have known that supports and reaction, that is, there are three types of supports. So where we have seen, that is, one is pinned support, roller support, and a fixed support. So pinned support is nothing but which consists of vertical reaction and the horizontal reaction. We consist of only two reactions. When we consider roller, so it gives me only one reaction. When it is a fixed, it is a three reactions. So one simple example I shall give you, that when I draw the free body diagram of this beam, so it's a beam with a UDL with a point load and the horizontal reactions. So summation of fx ha is 0. Summation of fy, that is ra plus rb, so it will become 5 into 2 into 2, that is the remaining moment. Rb into 4, that is, if I take moment about this point, I'll catch hold this point. Rb into distance is 4. Next, UDL. First I shall consider the force. 2 into 2 is my force. 2 into 2 is force. Now the distance is from half distance is 1 plus remaining length is 2. So therefore 2 by 2, that is half of this distance is 1. 2 by 2 is 1 plus 2, the remaining length, minus 5 into 1. Calculate the reactions R and RB I'll be getting. Now what shall I shall conclude that there are three equations of equilibrium and I have here three reactions. That means to solve this three reactions, that is HA, RA and RB, I need these three equations of equilibrium. I have three reaction, I have three equations of equilibrium. So therefore 3 minus 3 is equal to what? 0. That time I can say this structure as a determinate structure. If it is not 0, if it has any other intensity of number, then I can say it as indeterminate structure. So here one simple example, you can pause the video and you can see the example. Here we have three reactions: horizontal, moment and the vertical force, and here also we have the vertical force. So we have reactions is 4, but we have equation is 3. That means 4 minus 3 is equal to 1. Hence I can say this equation as a indeterminate structure. So this is about the determinate and simple way determinate and indeterminate structure. Now coming to the assumptions, what all we make in the analysis of stress. That is, as I said, the joints are assumed to be pin connection. That means it is always a hinged or a roller support and cannot resist moment. So I told you there is only the vertical force or the horizontal force, but there is no moment existence in it. Next, second, loads on the truss are applied at the joint only. So we cannot apply in middle, we can only apply at the joints of the structure. The member of a truss are purely subjected to axial forces. I said you that these forces will be in axial. Axial means I can pull it or I can push it, but I cannot bend it. So that is the point. All the members are uniform in cross section. So the member is uniform in cross section. It cannot be a two different way. So that's why the section should be uniform. The self weight of this structure can be ignored. That means the structure weight can be ignored, it's very negligible. So that's why we neglect or we ignore the self weight of the structure. The next part is the stability criteria. So what is the stability criteria? So stability criteria, that it gives a formula to calculate that M is equal to 2J minus R. So what is M? M is the member, J is the joint, R is the reaction. So what is a member? Member is, now you can see a simple example here. There is a small triangular truss which consists of two reactions. So we have members 3. So I have substituted 3. Joints, J means the joints 1, 2 and 3 joints, and the reactions R is equal to 3. So the reactions are 3. So substituting in this formula, so 3 is equal to 2 into 3 minus 3 is 6 minus 3 is 3. So members are 3 and the 2J minus R is also 3. Then I can say this structure as the stable. So this is the criteria for stable condition. So how many members are there? That much it should be the reactions. So that is called as a stable structure. The next one simple example, one more simple example I shall give you, that is a square truss where it has members, again 4 members. Members are 4, joints 1, 2, 3 and 4 joints. Reaction is 3. So 3 reactions are here. So therefore substituting in the formula, 4 is the member is equal to 2 into joints is 4 minus 3. So 4 is equal to 5. So that means it is not equal to 4. That means it is deficient. The reactions are 3 but the members are 4. So that's why it is called as deficient truss. So now one more example where 2 extra members have been added. So the members will become 6. The joint will become 4. R is 3. So substituting in the formula, we will get 6, but here the reactions will be 5. So I can say this type of truss is nothing but a redundant truss. So to completely analyze this type of analysis of truss, we need to solve one simple example. If I solve one simple example, it will be more easier for you to analyze or more easy to understand the simple about the simple trusses. So here is the simple example that will be done in our next video. So we need to find the forces in these members and all. So how to calculate this and all, everything will be done in the next class or the next session. Thank you.